So let us finish with this tutorial. This is the third and hopefully last part of this series of tutorial that shows how to use uh, AWS Application Serverless Modeler to create an application that creates a JSON and save this into S3. And then the last part of this tutorial, what we want to do is for each JSON that is deposited into an S3 location, we would like another glue job to take that information and store it as a parquet. It's a partitioned file with a schema imposed, um, and create a data table with that. So for that, you have been following these tutorials. You should be. We created this application.py function during our last video, alongside with this template.yaml and this resource here. And what I'm going to do right now is to create two new folders in my structure. There's going to be this glue job folder and this S3 trigger folder. And we need within each folder, I'm going to create a file. The file within glue job folder, which is going to be called S3 JSON to S3 parquet.py, and the file within S3 trigger folder is going to be S3 lambda trigger function.py. Those files I'm going to take from this repository that I have also previously uploaded. If I go to AWS Data Faker, then functions, I'm going to see a folder called glue function, then another called S3 trigger. You need to copy each of the functions here. So the glue functions, you are going to copy to this file under this folder. And the S3 trigger, you are going to copy to this folder. So you can see here the trigger function has exactly the same that I have here in this GitHub website. And after you have created these two resources, and then you update your template YAML accordingly. So in this template YAML, you need to add another Lambda trigger function creation. And then you need to add a glue job role creation. And also this S3 JSON to S3 parquet. After that, we need to add this trigger either again by doing it with infrastructure or coming here directly to the trigger function. You need to come here. This option in Spanish is desencadenadores. I believe in English would be as triggers. Add new trigger and add this trigger that I already have here, which is going to point to the bucket in which we are creating the JSONs, and it's going to be activated each time an object is created. So you need to go agregar desencadenador or add trigger, and then select S3, and then select the bucket, which is this one JSON trigger, and then select put, and then if you want to add a prefix, or if you want to add a suffix, etc. I'm not going to do this because I already done it. My trigger has been created, but you need to do that whenever you have uploaded this Lambda trigger function. You need to be sure that there is a trigger here that is pointing to this folder where we are depositing our JSONs. And once you have done that, we can go back to this previous, to our previously deployed Lambda function that is creating our JSON. And we're going to click on test, and this is going to run successfully output. And says that it has created this file under this location. And once a file has been deposited at some point on this location, what's going to happen is that this second trigger is going to be invoked. And when this trigger or this function is doing, when it is being invoked, subsequently is invoking this glue job that I have over here. You can see these instances of a succeeded job happened again. I'm going to run this again so we can observe this. I'm going to close this one and I'm going to test. It's a very short job. It only lasts for 14 seconds, 16 seconds. And here we have it, it is running. And what this job is doing is taking, here in input arguments, we can see, he's taking this file located at this location with the same that is being generated here. Let's see, 9037, 9037. And after finishing running, what this job does is just takes whatever is located in that JSON file. It chooses a database to save the information, a table. It creates a database. If it does not exist, if it exists, it continues without error, and then it creates the file. This location, appending to this database with this table name. If we go to Athena, if we go to query editor and see that we have this database along with some other that I have previously created again. Let's try to focus on this one. This one is the one that has just been created, that has 3 records, 1 record for each JSON that I have been creating. And if I, let's see the last record that was D9037, Christine Duran. Here it is, Christine Duran. This is the last record that was inserted. And if I click into this again, test, the corresponding JSON was generated. The corresponding parquet is being transformed. We should see this record ed2f inserted here. So if I execute this again, I see 4 rows. The last one being Chase Oliver, ed2f, Chase Oliver, with user ID. I see the user ID is not being recorded for some reason, but here we have the path ed2f. So with this video, we are concluding this series of tutorial. In the first part, we saw how to deploy that simple Hello World application using serverless application model. In the second part, we saw how to deploy an application to generate a JSON file, a JSON document, and save it into AWS S3 object storage. On the third part, on this part, we are seeing how we can take that JSON, each of these JSONs, and convert them into a parquet. Also, how to register them automatically into AWS Glue catalog. What we are doing now is AWS default Glue catalog. It's called AWS data catalog. In here, we can create as many tables as we would like and then insert as many rows as we would like when they are in Parquet format, as we just saw. And then, well, again, that will conclude our tutorial on how to take information automatically from a JSON file to a Parquet. This pipeline can be escalated so that imagine you have any amount of files arriving at the same time. We'll have same amount of jobs running at the same time, converting each of the files. So this is a very scalable pipeline. Let's see if we can actually poke this map data faker. Let's see. I test this. Let's hope this one without. This, we need this key in our event, so let's add it, this key, and let's run 10 users. So save, event 2, save, and then invoke, and then max transactions. We also need this keyword. We're going to add 20. We're going to save, save, and invoke. Well, let's leave this video here. The point is that as for any number of files that you are depositing here in concurrency, you should be able to execute as many of these jobs at the same time. Thank you for following the video. We'll see you next time.